artificial intelligence, the new industrial revolution. At its heart, Nvidia GPUs, invented here in America. Like electricity and the internet, AI is essential infrastructure. Every company will use it, every nation will build it.
Winning this competition will be a test of our capacities unlike anything since the dawn of the space age.
And today, AI factories are rising, built in America. For scientists, engineers, and dreamers, across universities, startups, and industry.
I think we want to try to reach new heights as a civilization, discovering the nature of the universe.
And now, American innovators are clearing the way for abundance, saving lives, shaping vision into reality, lending us a hand, and delivering the future. We will soon power it all with unlimited clean energy. We will extend humanity's reach to the stars. This is America's next Apollo moment. Together, we take the next great leap to boldly go where no one has gone before. And here is where it all begins.
Welcome to the stage, NVIDIA founder and CEO, Jensen Huang.
Washington, D.C. Washington, D.C., welcome to GTC. It's hard not to be sentimental and proud of America. This is the Super Bowl of AI, people say. Most people talk about the GPU. The GPU is important, but without a programming model that sits on top of it, and without dedication to that programming model, keeping it compatible over generations. We're now CUDA 13 coming up on CUDA 14. Hundreds of millions of GPUs running in every single computer, perfectly compatible. If we didn't do that, then developers wouldn't target this computing platform. If we didn't create these libraries, then developers wouldn't know how to use the algorithm and use the architecture to its fullest. One application after another. I mean, this is really the treasure of our company. cuLitho, computational lithography. It took us nearly 7 years to get here with cuLitho, and now TSMC uses it, Samsung uses it, ASML uses it. This is an incredible library for computational lithography, the first step of making a chip. Sparse solvers for CAE applications. cuOpt, a numerical optimization, has broken just about every single record. The traveling salesperson problem, how to connect millions of products with millions of customers in the supply chain. Warp, Python solver for CUDA, for simulation. cuDF, a data frame approach, basically accelerating SQL, data frame databases. This library is the one that started AI altogether, cuDNN. The library on top of it, called Megatron Core, made it possible for us to simulate and train extremely large language models, opened new markets for us. Let's take a look at what CUDA-X can do.
Ready, go!
Everything you saw was a simulation. There was no art, no animation. This is the beauty of mathematics. This is deep computer science, deep math, and it's just incredible how beautiful it is. Telecommunications is the backbone, the lifeblood of our economy, our industries, our national security. And yet, ever since the beginning of wireless, where we defined the technology, we defined the global standards, we have a big partnership with Nokia. Nokia is the second largest telecommunications maker in the world. It's a $3 trillion industry. Infrastructure is hundreds of billions of dollars. There are millions of base stations around the world. If we could partner, we could build on top of this incredible new technology, fundamentally based on accelerated computing and AI, and for the United States, for America to be at the center of the next revolution in 6G. So today we're announcing that NVIDIA has a new product line. It's called the NVIDIA ARC, the Aerial Radio Network Computer. This CUDA-X library that I mentioned earlier called Aerial. Aerial is essentially a wireless communication system running on top of CUDA-X. We're gonna create, for the first time, a software-defined, programmable computer that's able to communicate wirelessly and do AI processing at the same time. This is completely revolutionary. We call it NVIDIA ARC. And Nokia is going to work with us to integrate our technology, rewrite their stack. NVIDIA ARC is also compatible with AirScale, the current Nokia base stations. So what that means is we're going to take this new technology and we'll be able to upgrade millions of base stations around the world with 6G and AI. Remember, the internet enabled communications, but amazingly smart companies, AWS, built a cloud computing system on top of the internet. We are now going to do the same thing on top of the wireless telecommunications network. This new cloud will be an edge industrial robotics cloud. This is where AI on RAN, the first is AI for RAN to improve radio spectrum efficiency. The second is AI on RAN, essentially cloud computing for wireless telecommunications. Cloud computing will be able to go right out to the edge where data centers are not, because we have base stations all over the world. This announcement is really exciting. That's the best way to celebrate Nokia. Let's talk about quantum computing. 1981, particle physicist, quantum physicist Richard Feynman imagined a new type of computer that can simulate nature directly, because nature is quantum. He called it a quantum computer. 40 years later, the industry has made a fundamental breakthrough. 40 years later, just last year, a fundamental breakthrough. It is now possible to make one logical qubit. One logical qubit that's coherent, stable, and error-corrected. In the past, we now realize that it's essential for us to connect a quantum computer directly to a GPU supercomputer so that we could do the error correction, so that we could do the artificial intelligence calibration and control of the quantum computer, and so that we could do simulations collectively, working together, the right algorithms running on the GPUs, the right algorithms running on the QPUs, and the two processors, the two computers working side by side. This is the future of quantum computing. Let's take a look.
There are many ways to build a quantum computer. Each uses qubits, quantum bits, as its core building block. But no matter the method, all qubits, whether superconducting qubits, trapped ions, Neutral atoms or photons share the same challenge. They're fragile and extremely sensitive to noise. Today's qubits remain stable for only a few hundred operations. But solving meaningful problems requires trillions of operations. The answer is quantum error correction. Measuring disturbs a qubit, which destroys the information inside it. The trick is to add extra qubits, entangle, so that measuring them gives us enough information to calculate where errors occurred without damaging the qubits we care about. It's brilliant, but needs beyond state-of-the-art conventional compute. That's why we built NVQLink, a new interconnect architecture that directly connects quantum processors with Nvidia GPUs. Quantum error correction requires reading out information from qubits, calculating where errors occur, and sending data back to correct them. NVQLink is capable of moving terabytes of data to and from quantum hardware, the thousands of times every second needed for quantum error correction. At its heart is CUDA-Q, our open platform for quantum GPU computing. Using NVQLink and CUDA-Q, researchers will be able to do more than just error correction. They will also be able to orchestrate quantum devices and AI supercomputers to run quantum GPU applications. Quantum computing won't replace classical systems. They will work together, fused into one accelerated quantum supercomputing platform.
Let's talk about AI. What is AI? Most people would say that AI is a chatbot, and it's rightfully so. There's no question that ChatGPT is at the forefront of what people would consider AI. However, just as you see right now, these scientific supercomputers are not going to run chatbots. They're going to do basic science. Science, AI, on top of this infrastructure, which consists of giant data centers like easily many times the size of this room, an enormous amount of energy, which then transforms the energy through this new machine called GPU supercomputers to generate numbers. These numbers are called tokens. The language, if you will, the computational unit, the vocabulary of artificial intelligence. You can tokenize almost anything. You can tokenize, of course, the English word. You can tokenize images. That's the reason why you're able to recognize images or generate images. Tokenize video, tokenize 3D structures. You could tokenize chemicals and proteins and genes. You could tokenize cells. Tokenize almost anything with structure, anything with information content. Once you could tokenize it, AI can learn that language and the meaning of it. Once it learns the meaning of that language, it can translate, it can respond just like you interact with ChatGPT, and it could generate just as ChatGPT can generate. So all of the fundamental things that you see ChatGPT do, all you have to do is imagine, what if it was a protein? What if it was a chemical? What if it was a 3D structure like a factory? What if it was a robot? And the token was understanding behavior and tokenizing motion and action. All of those concepts are basically the same, which is the reason why AI is making such extraordinary progress. The software of the past, and this is a profound understanding, a profound observation of artificial intelligence, that the software industry of the past was about creating tools. Excel is a tool. Word is a tool. A web browser is a tool. The reason why I know these are tools is because you use them. The tools industry, just as screwdrivers and hammers, the tools industry is only so large. But AI is not a tool. AI is work. That is the profound difference. AI is in fact workers that can actually use tools. For the very first time, technology is now able to do work and help us be more productive. The list of opportunities go on, which is the reason why AI addresses the segment of the economy that IT has never addressed. IT is a few trillion dollars that sits underneath the tools of a $100 trillion global economy. Now, for the first time, AI is going to engage that $100 trillion economy and make it more productive, make it grow faster, make it larger. We have a severe shortage of labor. Having AI that augments labor is going to help us grow. Now I'm going to show you why. This is what's going on in our company's business. We're seeing extraordinary growth for Grace Blackwell for all the reasons that I just mentioned. I think we're probably the first technology company in history to have visibility into $500 billion of cumulative Blackwell and early ramps of Rubin through 2026. And as you know, 2025 is not over yet, and 2026 hasn't started. This is how much business is on the books. $500 billion worth so far. Now this is, out of that, we've already shipped 6 million of the Blackwells in the first several quarters, I guess the first 4 quarters of production, 3.5 quarters of production. We still have 1 more quarter to go for 2025, and then we have 4 quarters. So the next 5 quarters, there's $500 billion, $500 billion. That's 5 times the growth rate of Hopper. And then this new processor, I won't talk too much about it today, I don't have enough time, but this is completely revolutionary. And the reason for that is because your AIs need to have more and more memory. You're interacting with it more, you wanted to remember our last conversation, everything that you've learned on my behalf, please don't forget it when I come back next time. And so all of that memory is going to create this thing called KV caching, and that KV caching, retrieving it, you might have noticed, every time you go into your AIs these days, it takes longer and longer to refresh and retrieve all of the previous conversations. I have a second announcement. This is the single fastest enterprise company in the world, probably the single most important enterprise stack in the world today, Palantir Ontology. Anybody from Palantir here? I was just talking to Alex earlier. This is Palantir Ontology. They take information, they take data, they take human judgment, and they turn it into business insight. We work with Palantir to accelerate everything Palantir does so that we could do data processing at a much, much larger scale and more speed, whether it's structured data of the past, and of course, we'll have structured data, human recorded data, unstructured data, and process that data for our government, for national security, and for enterprises around the world, process that data at speed of light, and to find insight from it. This is what it's going to look like in the future. Palantir is going to integrate NVIDIA so that we could process at the speed of light and at extraordinary scale. Okay, NVIDIA and Palantir. These factories will have future robotic systems, and one of the most advanced is Figure. Brett Adcock is here today. He founded a company 3.5 years ago. They're worth almost $40 billion today. We're working together in training the AI, training the robot, simulating the robot, and of course, the robotic computer that goes into Figure. Really amazing. I had the benefit of seeing it. It's really quite extraordinary. It is very likely that humanoid robots, and my friend Elon is also working on this, that this is likely going to be one of the largest new consumer electronics markets, and surely one of the largest industrial equipment market. Now, humanoid robots is still in development, but meanwhile, there's one robot that is clearly at an inflection point, and it is basically here, and that is a robot on wheels. This is a robo-taxi. A robo-taxi is essentially an AI chauffeur. Now, one of the things that we're doing today, we're announcing the NVIDIA Drive Hyperion. This is a big deal. We created this architecture so that every car company in the world could create cars, vehicles, could be commercial, could be passenger, could be just dedicated to robo-taxi, create vehicles that are robo-taxi ready. The sensor suite with surround cameras and radars and LiDAR make it possible for us to achieve the highest level of surround cocoon sensor perception and redundancy necessary for the highest level of safety. Hyperion Drive Hyperion, is now designed into Lucid, Mercedes-Benz, my friend Ola Kalenius, the folks at Stellantis, and there are many other cars coming. And once you have a basic standard platform, then developers of AV systems, and there's so many talented ones, Wave, Wabi, Aurora, Momenta, Neuro, there's so many of them. WeRide, there's so many of them that can then take their AV system and run it on the standard chassis. Today, we're announcing a partnership with Uber. Uber, Dara K, Dara is going to, we're working together to connect these NVIDIA Drive Hyperion cars into a global network. And now in the future, you'll be able to hail up one of these cars, and the ecosystem is going to be incredibly rich, and we'll have Hyperion or robo-taxi cars all over the world.